Hello viewers, welcome back to my channel. I'm Dr. Dorcas Ngigi. We are going on with our topic, floating and sinking. Today we'll be looking at flotation. So welcome, let's go on together. So we're going to look at flotation. Okay, so what is flotation? Now flotation has to do with a body remaining on the surface of a fluid. So a body that is floating means it's not able to go deep into the fluid, and so it remains on the surface of the fluid. You can just say it's the opposite of sinking. So in the last lesson we looked at sinking, and we said that when a body is totally immersed in a fluid, then that object will experience an upthrust which has an upthrust due to a fluid equal to its own volume. Now today we are looking at flotation, and we are asking ourselves, why does a body float? Now we said if we have a body and that body is inside a fluid, assuming this body is not moving, it's stationary, then there are two forces that act on this body. It's weight, which acts downwards, and there's the upthrust force, which is directed upwards. Remember we said in the first video that this upthrust is due to the fluid itself. So the force, the upward force due to the fluid, we call the upthrust, and is directed upwards. So as you can see, the weight of the object and the upthrust are opposite to each other, and therefore, force being a vector quantity, we have a resultant force. The resultant force, which we said in the previous lesson, is the weight minus the upthrust, that is in sinking. Remember we said for sinking to happen, the weight of the object must be greater than the upthrust. And if that is the case, then the resultant force will be directed downwards. But today we are looking at flotation, and we are asking ourselves, then what would happen if this weight of the object and the upthrust were equal? What also would happen if the weight, if the upthrust was greater than the weight? Now, anytime there is a resultant force, the object should move with an acceleration according to Newton's second law. So an object which is experiencing a resultant force F, an object of mass m, should move with acceleration A. And this time, since we don't want our object to move, we want our object to float on the surface of the fluid without moving, then this resultant force F must be 0. So that time, the object will not go down, neither will it go up. So it will remain on the surface of the fluid. And that is the basis of flotation. So for flotation to take place, the weight and the upthrust must be equal. The weight and the upthrust on the fluid, on that object, must be equal. So when the two are equal, then the object floats. So very simple, it means that the upthrust on the object and the weight of that object are equal in flotation. And so we say that a floating body displaces its own weight. A floating body displaces its own weight. We also talked about upthrust, and we said the upthrust on an object is equal to the weight of the fluid displaced. The upthrust on an object is equal to the weight of the fluid displaced. Then it tells us the amount of fluid that we displace, the weight of the fluid that we displace, and the object that is floating, the two are equal. The weight of the object that is floating and the weight of the fluid that is displaced, the two must be equal in flotation. Okay, now that is flotation. So let's take an example so that we are able to understand better. So let's say we have a body of mass let's say 400 tons, with dimensions maybe 20 meter by 5 meter by 10 meters. Okay. Floating on fresh water of density 1000 kilograms per cubic meter. Okay, we have a body of mass 400 tons with dimensions 20 meter by 5 meter by 10 meters, and it is floating on fresh water of density 1000 kilograms per cubic meter. So question number 1, determine the upthrust on the body Question 2, determine the volume of water displaced by the object or by the body. And 3, probably calculate the length of the body inside the water surface, or below the water surface. Okay, now let's try to answer those questions together. Now, we have said that for a body to float, since our body is floating, then its weight and the upthrust on it are equal. So if we want to calculate the upthrust on this body, then we need to calculate the weight of the body. Okay. Now, to calculate weight, we know weight is mass multiplied by gravity. And so our upthrust is our weight, which is the mass, that is 400 tons. 400 tons is 400,000 kilograms. Remember, 1 ton is 1 kilogram, 1,000 kilograms. Okay, 1 ton is 1,000 kilograms. So 400 tons is 400,000 kilograms. Multiplied by gravity. Gravity is 10 newtons per kilogram. Okay, so the kilograms and per kilograms, of course, cancel. So we have, that is 4 million newtons. Now that is the upthrust, and this is also the weight of the floating object. It is the upthrust, and it is also the weight of the floating object. So we have answered the first part of the question, the upthrust. Okay, now we go to part 2 of the question. Determine the volume of water displaced by the body. Determine the volume of water displaced by the body. Now, how do we calculate that? Now, what is upthrust? Upthrust is equal to the weight of fluid displaced. So it means weight of water, of displaced water, is also equal to 4 million newtons. And don't forget, upthrust is equal to the weight of the fluid displaced. So flotation is simply a special case of Archimedes' principle. So water displaced, the weight of that water is 4 million newtons. So we can calculate mass. From this formula, if you want to get mass, you divide by gravity. Both sides is weight over gravity. Therefore, mass of displaced water becomes 4 million newtons divided by gravity, which is 10 newtons per kilogram. course, we are going back to the mass of the object. The mass of the object is equal to the mass of the fluid displaced, because the weight of the object is the weight of the fluid displaced. So mass of displaced water is equals to 400,000 kilograms. Okay. Now from there we can be able to calculate the volume of the displaced water. Now how do you go about that? We know that density is mass divided by volume. Is mass divided by volume. Therefore, to calculate volume, we multiply by volume both sides and then divide by density. So we get volume is mass divided by density. Okay, we already know the mass of displaced water, which is 400,000 kilograms. And we know the density of water. Density of fresh water is 1,000 kilograms per cubic meter. So I divide by 1,000 kilograms per cubic meter. Okay, so the kilograms cancel. So there are 3 zeros. Now remember, this is division. The meter here is raised to power 0. Any number raised to power 0 is 1. So 0, since it's division, so 0 minus, if you have m raised to power n multiplied by m raised to power x, that is m n plus x. We have m raised to power n divided by m raised to power x, that is m n minus x. So in our case here, it is m raised to power 0 minus negative 3. This is minus minus plus. So this is becomes volume is 400 cubic meter. So that is the volume of water displaced. So we have answered part 2 of that question. Now from that now we are asking ourselves, now how do we calculate the length of the object below the water surface? Now before we go to that, let's look at our object. The whole volume of the object, V of the body, is 20 meter by 5 meter by 10 meters, which is 1,000 cubic meter. Remember, meter times meter times meter, that is cubic meter. So that is the volume of the object. But the volume of the water displaced is 400 cubic meter. Now we know in sinking, we said in sinking, when a body is totally immersed in the fluid, then the volume of the object and the volume of the displaced fluid are equal. But here we are saying that the volume of the displaced fluid, which should have a mass of 400 tons, that volume is 400 cubic meter. What that simply means is, as this object is floating, there is that volume of the object that is below the surface of water, meaning inside the water, but there is also that volume of the object that is floating above the water surface. Okay, so it means this 400 cubic meter is the volume of the object that is inside the water. Then of course 600, if I subtract 400 from 1,000, then 600 cubic meter is the volume of the object that is floating above the surface of the fluid, or which is our water in this case. Okay, so we can be able to calculate the height inside the water and the height outside the water. Then if we can calculate that, then it means since this is our cuboid, that's 20 meter by 5 meter by 10 meter. Now let's say it is inside the water up to that point. So of course there is that part inside which we are, let's call it x. Then the part above is 10 minus x, because the whole height is 10. Now this x we can calculate, because we know this volume inside the fluid, inside the water, should be 400 cubic meter. Okay, so 20 meter by 5 meter by x should be equal to 400 cubic meter. Then this is 20 by 5, that's 100 meter square x should be equal to 400 cubic meter. Maybe I can clean this part. So 100 square meter x is 400 meters cubed. So we divide by 100 square meter both sides. 3 minus 2, remember, is 1, so that cancels, gives meter. So x is 4 meters. Okay, so the x here is 4 meters. So automatically the other part, 10 minus 4, that is 6 meter. Okay, so this object is floating with part of it inside the surface of water and part of it above the surface of water. So what can we see? We can see that the floating object, the volume of the floating object and the volume of the fluid displaced are not necessarily equal. What must be equal is the weight of that fluid that is displaced and the weight of the object. Those must be equal. But the volumes might differ. Like in our case here, we have seen that the volume of the object that has displaced the fluid is a volume of 400 cubic meter, meaning the volume of the floating object that displaces the fluid is that volume of the object that is below the surface of the fluid, or the volume that is inside the fluid. That is the volume that displaces the fluid. The volume that is above the surface of the fluid, or floating above the fluid, that volume does not displace the fluid. So with that, you can do more practice on that. And that brings us to the end of our lesson of today, flotation. So don't forget to like and subscribe. Have a nice time. Till the next lesson. Bye.